What if you could jump into a time machine and visit any point in history? Imagine, for a moment, that you have been given access to a device that allows you to traverse the vast chronicles of time. You could witness the rise and fall of empires, meet influential figures of the past, or even sneak a peek into the future. This idea, while alluring, has been the staple of countless science fiction narratives, captivating our collective imaginations. From H.G. Wells' seminal novel The Time Machine to the cinematic adventures of Back to the Future, time travel has been a fixture in our cultural landscape, a concept that continues to fascinate and bewilder. But here's the real question. Could time travel ever be more than a work of fiction? Is there a scientific basis that could make this fantastical notion a reality? The answer might not be as straightforward as you think. In our quest to understand the universe, we've stumbled upon theories and phenomena that challenge our very understanding of reality. Concepts that were once purely theoretical are now integral parts of our scientific framework. One such concept is the field of quantum physics, a realm where the ordinary rules of physics seem to take a back seat, and where the extraordinary becomes the norm. In this strange and fascinating world, particles can exist in two places at once, teleport across distances, and even influence each other instantaneously, no matter how far apart they may be. If these mind-bending phenomena are possible at the quantum level, could time travel be another mystery waiting to be unraveled? Today, we plunge into the world of quantum physics and explore a concept that might just bring us closer to understanding time travel: the Heisenberg Effect. Named after the German physicist Werner Heisenberg, this principle may hold the key to unlocking the enigma of time travel. So buckle up as we journey through the annals of time and delve into the mysteries of the universe. But remember, in the realm of quantum physics, things are rarely as they seem. Our quantum physics, a realm where the impossible becomes possible. At its core, quantum physics is the study of the smallest particles in the universe, the most minute elements that build up everything we see, touch, and experience. But when we peek into this quantum world, things start to appear a bit peculiar. Unlike the predictable mechanics of the larger world, the quantum realm is a playground of probabilities. Particles can exist in multiple places at once, only deciding their location when observed. They can even teleport through barriers, a phenomenon known as quantum tunneling. And it gets stranger. Particles can be entangled, leading to instantaneous changes over vast distances, defying our understanding of space and time. This is a world that challenges our intuition and stretches our imagination. But among all these strange occurrences, one phenomenon stands above the rest in its sheer defiance of logic. One such fascinating phenomenon is the Heisenberg Effect. Imagine trying to observe a tiny particle, only to find that your very act of observation changes its behavior. This is the essence of the Heisenberg Effect, a concept that seems more akin to a riddle from an ancient philosopher than modern science. Picture this. You're trying to take a snapshot of a particle, trying to pin down its exact location and speed at the same time. But here's the twist. This is fundamentally impossible. This isn't due to the lack of sophisticated technology or a flaw in your method. It's a principle of nature. It's like trying to catch a bubble without popping it. The more accurately you try to measure one property, the less accurately you can know the other. This is what's known as the Heisenberg uncertainty principle. Named after the physicist Werner Heisenberg, this principle is a cornerstone of quantum mechanics, which deals with the tiniest particles in the universe. It's not that these particles are just being stubborn or secretive, it's their inherent nature. They exist in a state of flux, a balance of probabilities rather than definites. Think of it like this. You're at a party and you see a friend across the room. You can see where they are, but you can't tell what direction they're moving in. Conversely, if you see them whizzing past, you can tell their direction and speed, but not their exact location. That's a simplistic way to understand the Heisenberg uncertainty principle. It's not just a rule, it's a fundamental aspect of the quantum world. This principle has profound implications for our understanding of reality. It tells us that at the most fundamental level, the universe is not solid, predictable, and deterministic. Instead, it's fuzzy, uncertain, and full of possibilities. So, while it may seem counterintuitive, this is the strange and wonderful world of quantum mechanics. This effect, named after physicist Werner Heisenberg, has profound implications for our understanding of reality. The Heisenberg effect is not just a quirky feature of quantum physics, it holds deep insights. An understatement, really, for this phenomenon that has forever altered our understanding of the universe. The Heisenberg uncertainty principle, the formal name of the effect, introduces a fundamental constraint on our knowledge of the universe. It states that we can't simultaneously know both the position and momentum of a particle with absolute precision. The more accurately we know one, the less accurately we can know the other. It's not a limitation of our measuring tools or techniques, but a fundamental aspect of nature itself. This principle, named after the brilliant physicist Werner Heisenberg, has profound implications for our understanding of reality. It suggests that at the deepest levels, the universe is not deterministic, where everything follows set laws and can be predicted with enough information. Instead, it's inherently probabilistic, where the best we can do is calculate probabilities. Consider a game of billiards. In a deterministic universe, if we knew the position and velocity of every ball and could calculate all the forces at work, we could predict the outcome of the game. But in a quantum universe governed by the Heisenberg effect, we can't know all those details. The best we can do is to calculate probabilities, and even then, the universe might surprise us. The Heisenberg effect also brings to light the concept of wave-particle duality. It suggests that particles like electrons and photons don't just exist as particles, but also as waves. And it's this wave nature that gives rise to the uncertainty in position and momentum. So in essence, the Heisenberg effect tells us that the universe is a bit like a magic show, where objects can be in multiple places at once, and nothing is ever quite what it seems. It's a radical departure from our everyday experience and intuition, but it's the best explanation we have for the behavior of the tiny particles that make up our universe. But what does all this have to do with time travel, you ask? Could the Heisenberg effect offer a gateway to the past or the future? As we delve deeper into the realm of quantum physics, this question becomes increasingly pertinent. The Heisenberg effect, a fundamental principle in quantum theory, introduces a world of inherent uncertainty. It tells us that we cannot know both the position and the momentum of a particle with absolute certainty. Now, why is this important for time travel? Let's think about it. Time, as we understand it, is a measurement of change. It's a sequence of events occurring in a particular order. But if we cannot know the precise state of a particle at any given moment due to the Heisenberg effect, doesn't it imply a certain flexibility? A wiggle room that could perhaps be exploited? In simple terms, the Heisenberg effect introduces a level of unpredictability into the quantum world. This unpredictability or quantum fuzziness could potentially allow for the bending of time. If we cannot pinpoint the exact state of a particle, then who's to say we can't manipulate that state? Could we not, in theory, influence the sequence of events and thus influence time itself? Theoretical physicist Kip Thorne proposed the concept of wormholes in space-time, which are essentially shortcuts through space and time. Now, if we combine this concept with the uncertainty principle of the Heisenberg effect, we get a potentially exciting possibility. Wormholes could allow particles or even larger entities to travel through time by exploiting the inherent uncertainty in quantum physics. Of course, this is all speculative. The mathematics of quantum physics is incredibly complex and we're only beginning to scratch the surface. But the potential implications of the Heisenberg effect on time travel are too intriguing to ignore. Remember, the universe is a strange and wonderful place, full of mysteries yet to be uncovered. So next time you dream of hopping into a time machine, remember, the key might just lie in the mysterious world of quantum physics. Our journey into the quantum realm and the mysteries of time travel comes to an end, but the exploration continues. We've delved into the depths of quantum physics, unraveling the enigmatic Heisenberg effect and its intriguing implications on time travel. These are not mere theories, They are the building blocks of our universe, the very fabric that stitches reality together. We've discovered that the Heisenberg effect is not just a footnote in a science textbook. It's a beacon illuminating the path to understanding the intricacies of time and space. We've touched upon the tantalizing possibility of manipulating time, a concept that has fascinated and perplexed humanity for centuries. Remember, every great discovery starts with a question, so don't let your curiosity be silenced. Dive deeper, probe further, and let your mind wander into the vast expanses of the unknown. Keep questioning, keep exploring, and who knows, one day we might just unravel the secrets of time itself.